Let's get right into it. Today, we're exploring a totally brilliant, game-changing concept that proves we can build fail-safe workflows not by pointing fingers and blaming people, but by fixing our broken systems. We're going to unpack a 60-year-old manufacturing philosophy that absolutely revolutionized quality control. And as you'll see, it directly applies to literally everything, from the software you use every single day to high-stakes scientific research. So think about a universal frustration we've all faced. When a mistake happens at work, who do you blame? Look, human error is completely inevitable, right? We all get tired, we get distracted, we miss things. But the way an organization reacts to that inevitable human error, that defines its entire work culture. Do you scold the person or do you fix the process? There's a really stark difference in how we can approach this. On one side, we have what human factors researchers call the person approach, or you might know it as the bad apple theory. This approach looks at an error and basically blames an individual's negligence or forgetfulness. But on the flip side, we have the systems approach. Now, this framework views errors not as root causes, but as consequences of vulnerable workflows. It assumes people are actually doing their best within broken systems. To prevent errors, you can't just tell people to try harder. You have to fix the system itself. To understand how to actually pull this off, we need to look at the legendary Shigeo Shingo. He was this brilliant industrial engineer who spent his entire career proving that, while mistakes are human, the defects they cause are entirely preventable. Starting back in the mid-1950s, he began teaching his principles to Toyota staff. And over the next decade, he developed these incredibly practical shop floor solutions that literally changed the world of manufacturing forever. His real breakthrough, though, came in 1961 at the Yamada electric plant. They were dealing with a massive headache. Workers assembling push-button switches kept forgetting to place one of two tiny springs under the buttons before closing up the case. And because the case was closed, that missing spring became a silent failure. The defect was totally invisible until the switch inevitably failed testing at the customer's site. For years, management's big solution was just to tell workers, hey, concentrate harder. But of course, thanks to ordinary human fatigue, that never worked. So what did Shingo do? Well, he didn't yell at anyone. He just changed the system. He placed a small dish right in front of the parts box and gave the workers a new workflow. First, take exactly two springs from the box and place them in the dish. Then build the switch using only the springs in that dish. It's so simple, right? Suddenly, if a worker forgot a step, a leftover spring sitting right there in the dish instantly screamed, hey, you missed a step, before the unit ever left the workbench. He made the error reveal itself immediately, and just like that, the defect rate plummeted to 0. Now, the history of how this concept got its name reveals something crucial about human dignity. Originally, Shingo called these devices Poka Yoke, which translates to foolproofing. But in 1963, a part-time worker at an auto plant actually burst into tears when a supervisor proudly showed off a new foolproofing device on her line. She thought they were literally calling her a fool. Shingo displayed some radical empathy here. He immediately scolded the managers for using that term and renamed the entire discipline to Poka Yoke, meaning mistake-proofing. He realized, if you want a quality system to work, you absolutely must protect human dignity. Which brings us to the formal definition of Poka Yoke. It's a quality assurance method for preventing mistakes entirely, or making them immediately obvious before they can turn into defects. It's built on this core belief that workers aren't the problem, the process is. It's all about designing tasks so a slip simply cannot happen. You're building quality in, rather than just trying to inspect it out at the very end of the line. To actually build a mistake-proof step, you need a mechanism to detect the error. Shingo categorized these into 3 distinct methods. First up, the contact method. This checks the physical shape, size, or orientation of a part. Next is the fixed value method. This ensures a set number of parts are used or actions are taken, just like that clever little dish with the 2 springs. And finally, there's the motion step method, which guarantees that steps happen in the exact right sequence. But once an error is detected, your system has to react, right? Poka Yoke systems generally fall into 2 reaction categories. The warning method will flash a light or sound a buzzer to alert the worker, which is helpful, but, it still relies on human vigilance to notice the alarm and stop working. The control method, on the other hand, is vastly superior. It physically stops the process until the error is fixed. It requires 0 human intervention to stop a defect right in its tracks. Okay, let's shift gears a bit. Because what's really amazing is that Shingo's 60-year-old manufacturing concept is just as vital today, especially in software engineering. Software developers have wholeheartedly adopted Poka Yoke to prevent user errors long before they can crash a system or compromise data. You actually interact with Poka Yokes every single day online. Think about Gmail. When you type find attached in an email but forget to actually attach a file, Google immediately hits you with a pop-up warning before you can hit send. Or think about websites that make you type a new password into two separate fields to make sure they match. Or those little password strength indicators. Those are all digital mistake-proving techniques.
And hardware engineers, they rely on this constantly too. A perfect example of the contact method is the SIM card slot on your cell phone. The card and the slot are deliberately shaped with this asymmetrical clipped corner. Why? So that a user physically cannot insert the card the wrong way. The design itself prevents the mistake.
But this concept isn't just limited to engineering. It's spread into rigorous academic science, too. Researchers are human, and they make mistakes, saving over files, transcribing data wrong, running bad code. Get this. One study analyzing psychology journals found that a staggering 49.6% of reviewed papers had at least one statistical inconsistency, almost half. To combat this, academics are now bringing systems-level mistake-proofing right into the lab. Borrowing directly from high-stakes fields like aviation and nuclear power, research labs are implementing what's known as a safety culture. This completely shifts the focus away from individual blame. It requires senior management to prioritize accuracy over just raw speed. It builds this shared concern for quality among everyone on the team, establishes strict, standardized rules, and most importantly, it requires ongoing reflection through blameless postmortems when workflows inevitably fail. One of the absolute best ways labs do this is by standardizing their protocols with tools like a shared project log. A really meticulous project log tracks exactly what was done, why decisions were made, and critically, who verified the work. By creating this highly visible paper trail of decisions and verifications, researchers build an airtight net. They catch the mistakes internally before bad data is ever submitted for publication. This relentless pursuit of perfection leads us right back to Shigeo Shingo's ultimate vision. He violently disagreed with the popular statistical process control method of his era. That method relied on sampling and basically accepted that a small percentage of defects was just the cost of doing business. Shingo, however, argued for zero quality control. His reasoning was profoundly empathetic. To the one customer who receives that single bad unit, the defect rate isn't 0.1%. For them, the defect rate is exactly 100%. He believed 100% source inspection, using cheap, tireless Poka Yokes, was the only acceptable path forward. And here is a totally surprising fact about Shingo's genius. He didn't just revolutionize quality, he revolutionized speed. He applied these exact same analytical principles to machine changeovers. Back in 1969, he looked at a massive 1,000-ton press at Toyota that took 4 grueling hours to swap out. By streamlining the workflow and separating internal and external setup tasks, he cut that 4-hour changeover down to roughly 3 minutes. 3 minutes. It was a feat that literally made just-in-time manufacturing possible. So, as we wrap up this explainer, I want to challenge you to look closely at your own workspace. Stop blaming your colleagues when things go wrong, and instead, hunt for the broken system. Ask yourself, what is the silent failure in your workflow right now? And more importantly, how can you Poka Yoke it today?